right, hey everybody. I just wanted to give you a video and just kind of explain negative exponents. And you'll see that I have another video to kind of help you with the worksheet, but I just wanted to give you an explanation of how we get these negative exponents. So let's start with something that we do know. So say, for instance, you have 5 to the first. 5 to the first means you have one factor of 5. If I do 5 squared, that means you have two factors of 5, okay, or 25. 5 to the third means you have 3 factors of 5, or 125. 5 to the fourth means you have 4 factors of 5, or 625, okay? All right, so we know that when you have positive exponents, that ends up being repeated multiplication. It's repeated multiplication of the same number over and over and over again. And we've seen a couple rules that we've been doing in the last few sections, okay? Now, what happens if I work my way backwards? So say, for instance, you have 5 to the fourth, and now we're going down to 5 to the third. Well, we take away a factor of 5 or divide by a factor of 5, okay? So 5 to the fourth divided by 5 leaves 125. If I keep going, 5 to the third down to 5 to 7, I'm taking away a factor of 5, or I'm dividing by 5. Again, I get 25. 5 squared down to 5 to the first, taking away another factor of 5. I'm dividing by another set of 5. I'm left with 5 to the first power, okay, or just 5. So if I'm adding factors, that's repeated multiplication. If I'm taking away factors, notice it's repeated division if I'm going the opposite way, okay? So let's say we keep going, okay, and let's say I take away another factor of 5, and that's 5 to the 0. Well, as my pattern shows, I'm going to take my previous answer and divide by 5. So notice if I take my previous answer 5 and divide by 5, I get this. 5 divided by 5 is 1. Okay, so here's a rule that anything raised to the 0 power is, I think my pen is dying, is 1. Okay, and you're going to see we're going to do a few more examples of that too, okay? But I'm not happy with that. I'm going to keep going, because why would I stop, you know? So let's say we go again, okay? Now let's say we have 5 to the negative first power. Well, my pattern's going to tell me I want to take my previous answer, which is 1, and divide by this 5. So 5 to the negative first is 1 divided by 5. 5 to the negative second is my previous answer divided by another factor of 5, or 1 over 2 factors of 5, or notice that's 1 over 5 squared, or I can write that as 1 over 25. 5 to the negative third is now I'm dividing by another factor of 5, so I'm dividing by 3 factors of 5, or 1 over 125. 5 to the negative fourth, which I ran out of room, would be 1 over 625, okay? So here's the thing with negative exponents. Positive exponents are repeated multiplication, okay? Keep adding factors of 5. But negative exponents mean repeated division. Not that the number is negative, but repeated division. So a rule for this, okay, when we're talking about these negative exponents, looks like this, and this is what the video is going to explain as well. So whenever you have a term raised to the negative power, it means repeated division. Positive exponent are repeated multiplication. Negative exponents are repeated division. So all the terms, remember, have a denominator of 1. So if you have a negative up top in the numerator, to make that positive, that'd be 1 over a to the nth power, okay? And when we're simplifying, you'll see here, all the directions say only positive exponents. So if you have a negative exponent, you have to move it, okay, to make it positive. You have to flip it, because what it's showing is repeated division. So say, for instance, we have 2 raised to the negative fourth power, okay? That negative doesn't mean negative 2 times negative 2 times negative 2 times negative 2. That negative exponent means repeated division. So that means 1 over 2 to the 4th. When you flip it over the fraction, you're showing it as repeated division. That makes the exponent positive. So that means 1 over 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 gives 16. 1 over 2 to the negative 4th is 1 over 16. Because remember, 2 to the positive 4th is just 16. 2 times 2 times 2 times 2. I think that was 4, but it is 4, okay? So the negative exponents mean repeated division. You have to flip it over the fraction bar, okay? Now, sometimes you're going to see here, that you're going to start simplifying with these, with the exponents as well. Okay, so let me show you a couple examples, and she's going to do these on some videos too. So say, for instance, you have 2y to the negative second. Okay, now remember, when we rewrite this, notice it doesn't have a denominator, but it's understood to be over 1. And in this case here, this negative 2 only applies to y. Why? Because there are no parentheses. So this means 2 times y to the negative second over 1. The 2 has an exponent of 1. The negative 2 only applies to the y. So in this case here, this means repeated division, not of the positive 2, but of the actual exponent. So the 2 is going to stay, because if you move this 2, then it would become a negative exponent, and that defeats the whole purpose of simplifying. But the y to the second goes in the bottom, and that becomes the final answer. If you have a problem like this, negative 4 over k to the negative third. Negative numbers are okay. All right, so negative numbers are okay, but negative exponents are not okay. Okay? Negative numbers are okay. So negative 4 is raised to the first power. What's not okay, I'm using my yellow again here, is k to the negative third. Why? Because this is repeated division, and you have to show it as repeated multiplication by making it positive, so you have to move it. Negative 4 is going to stay up top, but this k to the negative third has to go up top with that because it's negative. Negative 4 stays because it's raised the positive power. You're only moving negative exponents. And then the k to the negative third goes up top, and when you place it up top, you're showing it as repeated multiplication because it was negative on the bottom. And then your final answer is negative 4k to the third. All right, let me give you another example here, okay? Go back to, let's do teal this time. All right, so say, for instance, you have k to the negative third over negative 4, a to the 0, y to the fifth. All right, so like she'll mention in the video, I like to move things or circle things with negative exponents, okay? All right, so in this case here, I'll circle my negative exponent. So negative 4 is going to have to move. Notice this x to the negative third, I don't know what I just said. X to the negative third has to move because it's a negative exponent. The negative 4 on the bottom is going to stay because it's raised the first power. Here's another rule. Whenever you have a to the 0 or anything raised to 0, remember that gives 1. So that's going to cancel out. And y to the fifth is going to stay because it's a positive power. So I'll rewrite all the things are going to stay. Negative 4 stays on the bottom. Y to the fifth stays on the bottom. Remember that a to the 0 canceled out because it's just 1. Anything times 1 is 1. However, that x to the negative third also has to go on the bottom. Okay, when I move it to the bottom, it becomes positive. Now notice there's nothing up top. My final answer is just not negative 4y to the fifth, k to the third. Remember, everything always has, top and bottom, always has a factor of 1. So 1 stays and is always there. Final answer is 1 over negative 4y to the fifth, x to the third. Okay, very different from just negative 4, x to the fifth, y to the third. It's 1 over that. All right, you can watch the video for some more examples too.